Welcome to the channel. This time we are going to talk about a very important test related to speedometer, and that is 10,000 kilometer speedometer endurance road test or speedometer endurance test. 10,000 kilometer speedometer endurance test. The topic includes speedometer and its working, 10,000 kilometer speedometer endurance test setup, pre-test preparation and test procedure, midpoint and final inspection, evaluation criteria, key difference between analog and digital speedometer, post-test report, sample data log format, 10,000 kilometer endurance road test report template, and introduction to the next topic. A speedometer is a gauge or instrument used in automobiles, motorcycles, scooters, and auto rickshaws to display the current speed of the vehicle in real time, typically measured in kilometers per hour or miles per hour. In automobiles, the speedometer is located on the dashboard directly in front of the driver, whereas in motorcycle, it is usually mounted on the handlebar console, often combined with odometer and fuel gauge. Speedometer operates by detecting the rotation of the wheels or transmission and thereafter converting that motion into a speed reading using either mechanical linkage in older vehicles and electronic sensors, which are often based on pulse signal generated from the wheel speed sensor or transmission output shaft. This test is applicable to both analog and digital speedometers. Our objective is to assess long-term durability, accuracy, environmental resistance, and mechanical electrical integrity of the speedometer under real-world riding conditions across diverse terrains and climates. This test ensures that the speedometer continues to function correctly and reliably over an extended period, simulating a significant portion of the vehicle life cycle. Test setup. The test setup includes number one, distance. The test is to be conducted for 10,000 kilometer distance. Its duration that could typically range from 4 to 8 weeks. Route type, it should be a combination of highways, city roads, off-road, mountain, and coastal. The recommended weather conditions are hot, cold, rain, dusty, and with seasonal variations. Riding style, it should vary from mild to aggressive. The test can be conducted solo and with pillion, with, of course, luggage. Pre-test preparation include number one, baseline calibration. Ensure both analog and digital speedometers are accurately calibrated. Number two, data logging setup. Attach GPS-based speed logging equipment to benchmark actual speed. Number three, inspection checklist. Confirm sensor and cable conditions are optimal. Train riders to record anomalies, error codes, and behavior during the test. Test procedure. Initial test procedure step by step consists of the following. Initial benchmarking. Record speedometer reading versus GPS reading at 0, 20, 40, 60, 80, and 100 kilometers per hour. Record odometer reading. Number 2. Daily riding and logging. Cover 300 to 500 kilometers a day over diverse road conditions. Log any speed discrepancy, that is erratic behavior, flickering, or needle vibration in analog speedometers. Record environmental conditions, whether it is rainy or dusty, etc. Midpoint inspection, that is around 5,000 kilometers. Check and record the main important points, that is, if there is any cable, is there any cable wear in analog speedometer, any sensor alignment in digital or analog, display clarity, whether the LCD or OLED, that is organic light emitting diode, a displaying technology, or light emitting diode displaying technology is working properly or there is any damage. Is there any mechanical jitter or lag in analog needle? Is there any ingress of dust or water to the speedometer? On completion of 10,000 kilometer road test, then final report is to be prepared. Through fully dismantling of the speedometer unit, analyze for the following. That is internal corrosion. Number 2, is there any mechanical damage to gears and cables or cable lengths? Record any discrepancy in PCB integrity and solder joint health. Record LCD pixel degradation if any, or its segment failures. And finally, odometer accuracy deviation and any other important observation. The key points related to the evaluation criteria are to be evaluated. Number 1, accuracy drift. That is, in case of analog speedometer, record that is there any needle lag or mechanical play, and then record it in test results are yes or no. In case of digital speedometer, sensor signal stability is to be recorded, and is there any software error? Say yes or no. Durability. Regarding analog speedometer, cable or gears worn or fatigued? Yes or no? In case of digital, any PCB degradation or display aging, we have to record yes or no. Environmental resistance of the speedometer system. Is there any water or dust ingress in dial in case of analog? In case of digital, any water or dust damage to the screen or connectors. User feedback. Record user feedback regarding analog speedometer. Is there any vibration or noise from dial detected? Screen flicker or slow refresh rate in case of digital, and recording it in terms of yes or no. Odometer accuracy. Is the mechanical wheel tracking correct? In case of digital speedometer, any sensor pulse counting errors, they are to be recorded in terms of yes or no. Backlighting performance. In case of analog, bulb or bulb working without any fading or failure. In case of digital speedometer, LED or LCD displays shows no dimming or burn-in. Key difference between analog and digital speedometer in case of endurance test. Failure modes. In case of analog, it is cable snapping or gear slipping. In case of digital, sensor disconnection or software glitch. Serviceability. Analog speedometer are easier to repair in the field, whereas digital speedometer require often full replacement. Precision. Analog speedometer slightly less precise at higher speed. Digital Digital speedometer are of high accuracy if sensor works properly. Durability. In case of analog, mechanical parts can wear, whereas in digital speedometer, electronics may suffer heat and moisture. Post-test report. Generate a comprehensive post-test report which should include GPS versus speedometer data graphs at the start of the test, middle of the test, and at the end of the test. Failure logs. Any problem which created failures of any part or any other systems of the motor vehicles. Photographs of the internal damage if recorded. And finally, suggestions for design improvements. Here is sample test data log format. The dates are mentioned in this column, then odometer start and odometer end reading on this particular date and the distance covered. For example, on this date, rider covered 320 kilometer distance. On 2nd of May, rider covered 310 and thereafter on 3rd, 320 kilometer. Recorded route types, it was highway, it was city plus hills, it was off-road. Then the weather record, sunny, rainy, and dusty. Issues noted, for example, none on this date, flickering in LCD on 2nd of May, needle jitter on 3rd of May. GPS versus speedometer reading at 60 km per hour. GPS speed, GPS is 60, speedometer is 62. It is within the tolerance, so the comments are it's a good performance. Likewise, GPS 60, speedometer 65, LCD fogging was noted. GPS 60, speedometer 59, analog vibration issue was recorded on 3rd of May. 10,000 kilometer endurance test, road test report, complete template. Record the following: model name, enter vehicle identification number, that is VIN. What is the speedometer type, analog or digital? Enter the manufacturer name, then sensor cable, sensor type, whether it's a cable driven or Hall effect or ABS based. Test start date and test completion date. Pre-test calibration result. Before starting, we have the calibration results, which were recorded as follows. At a speed of 20 km per hour, GPS reading is 20 km, whereas speedometer reading is 20.5. That is deviation of 0.5. At 40 km, the speedometer reading is 41.0 km per hour with a deviation of plus 1.0. At 60 km, the speedometer reading is 62.0 with the deviation of plus 2.0. With 80, deviation of plus 3, and with 100 km, deviation of plus 4.0. Test summary is as follows. Total distance covered 10,000 km. Total days in test 30 days. Average distance traveled per day, that is 333 kilometers. Weather conditions covered sunny, cloudy, rainy, dusty, and cold. Terrain types highway, city, hilly area, and off-road. The observed issue summary is as follows. On the day 12, that is upon the covering of 4,000 kilometer distance, analog needle jitter was observed. That is needle vibration on rough roads. The issue could not be resolved. The cause was cable wear. On the day 5, that is upon covering of 1,500 kilometer distance, LCD flickering was observed. That is intermittent flicker in sunlight. The issue was resolved as the connector was cleaned. Continuously, odometer drift was observed. Odometer reads 2% higher than GPS. The issue is not resolved. However, 2% deviation is within the tolerance. Midpoint calibration upon covering 5,000 kilometer distance, the at the speed of 60 kilometer per hour, GPS reading, speedometer reading was 63, that is plus 3 kilometer per hour deviation. On 100 kilometer speed per hour, speedometer reading was 105, that is plus 5 kilometer per hour of deviation. Post-test finding. In case of analog speedometer, 20% cable fraying was noted due to wear, aging, or mechanical damage. Slight wear in the needle mechanism was also observed. There was moderate dust ingress under bezel, that is the ring or rim, surrounding the glass face of a gauge or display. In case of digital speedometer, minor correction at the connector area of PCB was noted. Slight dimming of backlight was also noted, and the sensor stability, no error code was observed. Final calibration. Finally, upon completion of 10,000 kilometers, when the GPS speed is 60 kilometer an hour, speedometer reading is 64, that is the deviation of plus 4 kilometer per hour. At a speed of 100 kilometer per hour, speedometer reading is 106.0, that is the deviation of 6.0. Conclusion. The speedometer test indicates that the part is declared as pass as the deviation is within the allowable limit and there was no major functional failures. However, the following improvements are recommended. Improve analog cable quality for durability. Seal digital display better to prevent condensation and dust ingress. Add real-time self-diagnostics for sensor signal loss in case of digital speedometers. The final reports includes the following attachments: raw log files in CSV or Excel format, photos of internal parts before and after, GPS versus speedometer overlay charts, and finally the maintenance notes. With this, we conclude our today's discussion on the part 1 of 10,000 kilometer speedometer endurance test. Our next topic would be part 2 of the same test, that is 10,000 kilometer speedometer endurance road test. Please do drop your comments and share your experience to further improve the content of this channel. Thank you, and thank you very much.